So welcome back to Code Arcade, guys. So today I'm here with you with a very interesting problem in DSA problem solving, of course. So today the problem that we're going to be solving is search in rotated sorted array. Okay, so let's take a look at the problem real quick. So as per the given here, we have to search in a rotated sorted array. Okay, the question is very clear, and I think we are able to understand the problem statement from the question. Okay, we are given an array which is sorted, but it is rotated. Okay, so let's see an example and understand how the array will be. So as you can see, this array is sorted but rotated. See 0 1 2 4 5 6 7, this is a sorted array, but this is a rotated, but it is rotated after it is being sorted. Okay, so that's the difference. Here we are given another integer, a target value. We just have to return the index of the target value. Okay, so I think if there is no such target value, you have to return -1 as per example 2 and example 3. Okay, I think the problem statement is clear. So let's jump right through to the logic. Okay, taking a look at the logic. Okay, so we have to search in a sorted array. Okay, and we have to do it efficiently. Okay, we know we can just we can just do it in a brute force approach. We can just traverse through every single element and find the target element and return the index. Okay, that's very simple. Okay, we don't want to do that. We want to solve this problem in an efficient way. I'm saying we can solve this problem in a log n time complexity. Okay, so that's the case here. So as per all we know that this is a rotated sorted array, but even if it's a rotated sorted array, it is a sorted array. We have a sorted array, and then we have to solve in an efficient manner. So what can we get from this problem statement? We can get that this could be done in some way like the binary search. Okay, so if it is the first thing that comes to our mind, if we see a sorted array is binary search, and if you want to find the target sum, definitely it's going to be a binary search, correct? So we cannot do a regular binary search in this array because hence it is rotated. Okay, we have to follow a different method of binary search. Okay, then how we are going to do this? Okay, let's jump straight through. So as you can see here, I can separate this array into two parts. Let's say I want to separate this array. I can separate this array into two parts, similar like this. This is one part, and as per we all know, this is one part. Okay, we can separate this array into two parts. How we are separating array into two parts? See here, this part is sorted and this part is also sorted, but the number between this part, let me take an example. This part is not sorted because after 5 0 is coming, correct? So that part is not sorted, correct? So we can separate this array into two sorted parts. Okay, now we can see that this 5 and 0, this part is not sorted, correct? So this non-sorted part is known as the pivot. Okay, we call it as a pivot. Okay, now as per our problem, our target value could be either in this part or in this part. Okay, so the thing we have to do is we have to just binary search. We have to find the pivot point. Okay, the pivot point where the point where the array is not sorted. Okay, the pivot point. And what we do is, see, from the starting element to the pivot point, it is one array, it is one part, and from the pivot point to the ending element, it is one part, correct? We just have to binary search both the parts and find our element. That's it, simple. Okay, so the first thing is we have to find the pivot point, and then we are going to binary search and we are going to find the pivot point, separate it into two arrays and two parts, and then just binary search through each part. Okay, remember guys, we can binary search a lot of times, but the time complexity will still be log n times. Okay, you can have 4 loops running at n time, running at n times. If you even have 4 loops, it will still, the time complexity will still be order of n. Okay, so we can binary search as much as time as we want, but the time complexity will still be log n. Okay, so let's jump into this problem right away. Okay, before jumping into the problem, we haven't discussed one part. How the hell are we going to find the pivot point? Okay, so we know how to binary search it. It's a simple algorithm. How the hell we are going to find the pivot point? Okay, similar we're gonna follow a similar binary search method. Okay, the thing that we're going to do is it's very simple. Just hold on with me. Okay, to find the pivot point, let's say as usual we are calculating. We have it as green. Let's have we first will have the start pointer, right? Start pointer, have the end pointer. When we calculate the bit, what will be the mid? 0 plus 1 2 3 0 plus 0 1 2 3 4 5. 0 plus 5 by 2 is 2. So 1 2 5 will be the midpoint. Okay, so midpoint is going to be 5 here. Now we have to find the pivot point, correct? So the pivot point can either be the left hand side of the midpoint or it can either be in the right hand side of the midpoint, correct? So you have to find which side the pivot point is to the mid, correct? How we are going to find it? Let's take the midpoint and let's say if the midpoint, the value of the midpoint, okay, which is 5. Let's check if 5 is greater than 2, okay, greater than the last end element. If it is greater now, then the pivot is definitely somewhere around here, correct? Pivot is definitely somewhere around here. If it is greater now, what it means? If 5 is greater than 2 now, then somewhere in this part of the array only the values are not in ascending order. If you take a sorted array, the value will keep on increasing. The midpoint should not be less than the ending point, correct? Should not be greater than the ending point. But here in our case it is greater. So the pivot point should be somewhere around here, correct? Then we'll calculate the midpoint again. Now let's check if the midpoint is greater than the ending point, which is no. Then we'll just have our ending point move to here. Okay, now we will calculate midpoint. Midpoint will be here. Let's check if it is greater than 2. No. Then we will just move the ending pointer here. Once the ending pointer comes here and the starting pointer goes here, we can just come out of the loop because we have our pivot point 0. Okay, and we can just return our starting pointer. Okay. Now this is how to find the pivot. After finding the pivot, we separate the arrays into 2 parts and then do a binary search. Okay. So let's get coding right away. Okay, the first step we have to follow is find the pivot point, correct? So I'll have my starting pointer. Okay, let me just get my indentation correct. I'll have my starting pointer at 0, sorry, no semicolon, and my ending pointer at len of nums -1 because it's 0 based indexing. Now let me just find the pivot pointer. So find the pivot pointer is just a normal binary search, similar to normal binary search approach. So my starting pointer should be less than or equal to my ending pointer. Unless it is less than or equal to, I have to run this loop. So let me calculate the mid pointer. M is equal to S plus E, my bracket, divided by 2, correct? Okay. Now let me check. Well, what we have to check? We have to check if the mid pointer, not the mid pointer, the value corresponding to the mid pointer is greater than the ending pointer. Value corresponding to the ending pointer. Okay. Sorry for that. If it is greater now, then we have to move our starting pointer to mid plus 1. My starting will be mid plus 1. Correct? Okay. Else my ending I should move to just mid. Okay, don't need to move to mid plus 1. Okay, at the last of this loop, okay, the simple mistake I made is after coding hours of JavaScript, I forgot that Python is not based off brackets. Okay, just forgive me for that. All done. Okay, sorry for the indentation bar. Okay, now at the last I'll have a variable called pivot. Okay, at the last the pivot will be in the starting pointer. Looks good, sounds good. Now The next thing that you have to do is we have to binary search. Now we can just separate the array into two parts and we can just binary search through them. So we'll have a function to binary search. So def binary search. Okay. For binary search we need the left and right pointer, correct? So I'll have my left and right pointers as input. Okay. Sounds good. Okay. Now I just have to do this, and inside this I can just do a regular binary search while my left pointer is less than. I'll just have the starting and ending pointer as it is more clear. Starting and ending, as my starting pointer should be less than or equal to my ending pointer. If it is less than, then I have to calculate. Okay, sorry for that. Okay, I just remembered my mid pointer should be s plus e divided by 2, correct? After that I just have to check if my target value is less than my nums of mid. That means I have to move my end pointer to mid minus 1, correct? And then LF, if my target value is let's say it's greater than my nums of mid, binary search, if it is greater than my nums of mid now, then my starting value should be moved to mid plus 1, correct? Okay. Else if it is not both the case, then my mid value is the target value, so I can just straight up return the index which is mid, correct? Regular binary search, simple. Okay. Now after this I just have to binary search through the both of the parts. So I will just say I have a variable called res. I'll just binary search. So binary, let me just binary search. Okay, what happened here? Let me just. Okay, I just have to. The first part is from the 0 element to the pivot minus 1, of course, because it's 0 based indexing, and then I just have to check if the element is actually in this part. So if my res is not equal to minus 1, okay, let me just check. Okay, let's just say it is not in this loop. If it is not in this binary search loop, let me just return minus 1 as per the problem, of course. Okay, here I just have to check if it is not equal to minus 1. If it is not equal to, I can just straight up return my res. If it is, suppose it's equal to minus 1, it is in the other part. So let me just return this part, binary search of, I have to search from pivot to the last len of nums minus 1, correct? So let's say looks good, sounds good, correct? So let's see if the problem works. Okay, I just did a few minor changes. I just changed the variable name to full form because it looks real good. So that's it, all the test case passed. Okay, so thank you for watching, guys. See you on the next interesting problem. Bye.